Hello student, welcome to lesson 3 where we are going to look at CRO and TV tubes. And in here we are going to start with horizontal diffraction, or what we call the X plates. Now when the plates are arranged alongside, the beam of electron will be diffracted horizontally as shown in our diagram. It will be moving from N through O to M. And if the polarities are interchanged, you will find now it will be moving from M through O to N. So this one is what we call now the X plates, the way they are arranged alongside. Now in a CRO, these X plates are internally connected to what we call the time-based circuit. And this time-based circuit, it applies a sawtooth voltage on the X plate. In other words, the voltage increases uniformly to a peak voltage, in other words that we call it sweep, and then drops suddenly to a maximum negative value. In other words, it flies back as shown in our diagram. So it is this time base, it is moving, increasing to the peak voltage at this particular point. Then it flies back to the maximum negative value here. So this one is what we are calling the peak voltage. This is the maximum negative value. So we have the flyback and the sweep. So this is the type of the voltage that is connected to our X plates. So it implies that when this one is on, the time base is on, then it causes the spot to fly back to the starting point at the head of the screen. So it will fly back, it will move to the peak, then it flies back. Then the speed with which the electron beam sweep is adjusted by what we call the time-based knob. In our screen there will be that time-based knob that can control the speed of sweeping. So the higher the frequency, the shorter the time of sweep. And we have the typical values of this time base. We have 10 milliseconds per centimeter, or 100 milliseconds per centimeter. So when a DC voltage is applied in the Y input or the Y plates, remember we have said that in Y plates it causes the vertical diffraction. So if we connect that to DC and at the same time we connect the time base on, remember now we have the Y plates causing the vertical deflection, and we have the time base that is causing the horizontal deflection. Then when the two are on, the horizontal line is seen to move towards the positive plate as shown in our diagram here. But when an AC voltage is applied to the input of a CRO, that is the Y plates, and the time base is on, so we are saying that instead of now using a DC current on the Y plate, we replace that with an AC. And then we ensure that the time base is on. So we shall have now the vertical deflection and the horizontal deflection. Then the two will interact. That is, we will have the interaction due to sawtooth voltage on the X plates and the AC voltage on the Y plate. Due to that interaction, we shall have now a sine curve. In other words, as shown in this diagram. In our first case here, this is when we have the time base is on. This one, the time base, it is moving on a horizontal direction. Then the Y plate is on. It is moving vertically. Now when you combine the two, we form a sine curve. And this is what will be observed on our screen. So the purpose of the time base is to move electrons across the screen at a particular speed, and this will enable us to study the variation between the voltages with the time. Remember we said that the screen can measure the voltage. It can measure the voltage. So it is measured when we display this sine curve. We can be able to use the screen and the time-based current to get the particular voltage that is being displayed by that curve. Then from there, we have the display system, the screen. Now, inside the screen is coated with phosphor, what we call the zinc sulfide. And this one fluorescence, or it glows when the electron strikes them. We said that the kinetic energy of this electron is converted to light when it hits the screen. And that light is the one that is making the screen to glow. And when it glows, we observe a bright spot. That way, it prevents the screen from getting heated, because all the kinetic energy is converted to light energy. But remember, we are saying that this screen is coated with these materials, the phosphor, that can fluorescence when these electrons hit them. Then the inside of the tube is coated with graphite, and the graphite has the following function. One, we have the earthing, and this is the conduction of electrons to the earth. Then number two, it shields the beam from the external electric field. Then number three, it accelerates the electron towards the screen, because this graphite, it has the same potential as the anode. So the graphite has those three functions: earthing, then shielding the beam from the external electric field, and number three, accelerating the electrons towards the screen. Then we have our screen here. This is what we are going to get in our screen. This is the display. This is our sine curve. All these are the knobs that are able to be adjusted so that you can control the frequency, you can control the speed of the sweeping. So that way you are able to get the desired curve that you want. Then from there we move to TV tube. Now a television tube is a cathode ray tube with the following modification. One, the deflection of the spot is by magnetic coils. Remember, in our cathode ray oscilloscope, the deflection is due to electric field. But in here, the deflection is due to magnetic field. And this one is being made possible due to what we call the magnetic coils. Now, why do we use magnetic coil or the magnetic field? This is because they provide a wide deflection to the light to light the whole screen. So this one provides a wide deflection. Then the second modification, this is what we call the TV tube, as you are going to see. These are the diffracting coils. These are the magnetic coils. They give us a wide deflection. So number two, we are saying that this is possible, or this makes it possible to work with a wide screen with relatively short tube. If you compare the length of a cathode ray oscilloscope and of the TV tube, you will find that this TV tube is shorter. And this is because it is using what we call the magnetic field that is giving us a wide deflection. Then the tube has tiny plates which combine, or we have the two tiny plates which combine to the light or to light the entire screen instead of just a line. It has two tiny plates, and those tiny plates combine so that it can light the entire screen. Remember, in our CRO, we are just seeing a point or a bright spot. But in here, on our TV tube, it is lighting the whole screen. And this is made possible because we have these tiny plates. Then number two, or the second modification, is that the incoming signal from the aerial is fed into the grid. And this affects the vibration of the intensity of the beam as it sweeps across the screen. So the incoming signal is fed directly to the grid, and this will cause the variations of the intensity of the beam as it sweeps across the screen. The dots of varying brightness is excessive line, or in other words, these dots, because they vary in brightness, they form or they build a line, and that line in turn, it forms an image, and that image is what is observed on our screen. And because this occurs at a very high frequency, and we have what we call the persistence of vision, then in other words, the high frequency and the persistence of our vision gives us an impression of a steady picture that we observe on our TV tube. Then from there, we have that in our color TV, we have 3 electron guns, and each gun has the one primary color. It has the red, it has the blue, and it has green. So each electron gun, there are 3. Each one has the primary color. So the first one has the red, the second one has the blue, and the third one has the green color. So it implies that the screen has a matrix of different color emitting phosphor dots such that they are stimulated, and when they are stimulated, those phosphor dots, they give us the colored picture. But in black and white, you will just, it has only one electron gun, and that is why you can't be able to form a colored picture. Then the coils are mounted outside the neck of the tube so that they can be treated and adjusted while set is being assembled and tested. So we have the differences between the TV screen and the CRO. One, we have seen that in TV tube, the diffraction is by magnetic field, but in CRO, the diffraction is by electric field. Then in TV, it has 2 time base, but in CRO, it has only 1. Then in TV, we have electrons that light the whole screen. They light the whole screen, but in CRO, they produce a spot. Where they are falling, they produce a spot or a dot or a line. In TV, we have 625 lines per second, but in CRO, we have only 25 lines per second. And from there, we have the assignment. Again, attempt the assignment with confidence. You are able to do it and get everything. You are born a winner. So thank you, and let us meet in our next lesson.